Go ahead.
Great. I'm I'm Dave Tenney. Um, some folks saw a talk that I gave on why you might want to consider Common Lisp versus Clojure. I've spent 10 years earning my living with Clojure, and a long time ago I used to earn my living with Common Lisp, and I kind of gave it up about the year 2000. Lisp, it wasn't always a very friendly environment in the computer industry for Lisp. And then eventually I came back. I found Clojure on the JVM after writing an awful lot of Java code, and that was great. Clojure's been great. But recently, I've sort of come full circle and have decided that there's a lot of things to be appreciated about Common Lisp. And if you've never used another Lisp besides Clojure, or if you're thinking about Common Lisp, well, I wanted to go through some things, give you a few demonstrations of things I like about Common Lisp and so forth. And I don't know how you handle questions here. Uh, Whatever
It's
you
up
want to
to
do is
you.
fine.
Do you want the questions at the end? Do you want it in the middle?
No, no, there's not so many people here, so I can be interactive.
Well, this is quite a quorum, to be honest. This is like 8 people.
I must have more friends than I thought I had.
Oh yeah.
Anyway,
So your reputation is doing the game. Congrats.
some of you I have enjoyed working with in the past, and hopefully we'll work again in the future. So anyway, here we go. Let's talk about Common Lisp. So I'm going to switch over. I have to share my whole screen because there's a website I want to share as well as things in Emacs.
Sure.
Uh, here's the prelude. I like Clojure. I'm going to say a lot of things that sound like I don't like Clojure, but I do like Clojure. That's why I've been using it these last 10 years. And I'm really grateful to Rich Hickey and Clojure for bringing really a whole new generation of people into the Lisp arena, and also, incidentally, Emacs. I'm glad to see people using Emacs rather than have it all go the way of the dinosaurs. So this has been a really nice time. And Clojure, Rich Hickey did so many things right, right? It's a thoroughly modern Lisp, uh, whereas Common Lisp has basically not changed in a long time. And partly that's because Common Lisp is an actual ANSI standard. Uh, whereas Clojure, like Python, is sort of got the benevolent dictator. Common Lisp was standardized. A bunch of people with a bunch of competing Lisp implementations got together week after week, month after month, year after year, and fought over, how are we going to do this so that we can make a Lisp standard that works for all of us? Because the Lisps back in the 80s had a lot of different origins. And then you had Lisp machine vendors like Symbolics, like Lisp Machines Inc., and they all had their little things that they relied on in their Lisp in order to ship their product. But for all that Common Lisp may have a few dark or may show a, the fact that it's a standard is pretty amazing and buys you some benefits, not least among which is you can go out today and find a dozen different standardized Common Lisp implementations that have different fortes. Anyway, we'll go into that. Uh, Rich set out to give you tools to solve the so-called expression problem, so that if you had code in the field, that customers could uh, upgrade, extend your code without having to require access to your source code. And he solved that problem. And so you have tools like his version of Def Multi and Extend Protocol. And I'm going to show you the Common Lisp versions of these things. I can't say that Common Lisp solves the expression problem quite as well as Rich did, but when I use the Common Lisp tools, it feels much more like a batteries included experience. Implementing your def multi dispatch method to do the things that Common Lisp does is more difficult than you might think. Anyway, so I already went into some of this. A lot of my the favorite I've ever have or some of my favorite software projects ever have been things that I've done in Common Lisp, products that I've shipped in Common Lisp, games that I've written in Common Lisp. They've just been the most fun things. They're the thing, when you look back on a lot of years of all the projects you work on, you sort of rank them. What was the thing that was most fun for you? And for me, Common Lisp projects were very fun. Clojure was also very fun. And one of the things about Lisps in general is that it makes possible things that otherwise would be impossible because we go by this metric of, every line of Common Lisp code is 7 lines of code in some other language. And that might not be as true now as it was in the 80s, but it's still a big advantage. And I've had multiple projects where, for example, I wrote a project that written 70,000 lines of directive C. I mentioned already that there are a dozen implementations of the Lisp standard. And a short way to show you where they are, if I can find it, is, for example, this Common Lisp portability guide will list all these different Common Lisp implementations and various packages that you might be interested in using. So since it hasn't really evolved since about 1992, one of the things Common Lisp did not address was concurrency. Back in the 80s, none of us had multi-threading machines. Most of us didn't, rather. But so there are packages that have been designed to run on mini Lisps that give you threading or foreign function interfaces and atomics like compare and swap and so forth. And so this is a matrix that you can look at which Lisps support it. A Lisp that most of us use if you want to get started with Common Lisp is SBCL on this right-hand column. SBCL is free, it runs everywhere, and it supports pretty much everything. As you can see, it supports all of these packages for threading and what have you. And that's what I'm going to be showing today. But all of these, there's a lot of fine Lisps on here, CCLs, and so forth. And some of these are commercial Lisps. You can actually get paid support if you want additional things, additional support. And some of these Lisps, example, one of the things about Lisp is are oriented towards a code generation thing. They are not running through a JVM or something like that. You can get them to generate machine code right into your running image. And they do that in different ways. Or some of them will do things like generate C code. You define a function, it generates a C file, compiles it, links it into your image. That can be useful if you're trying to do embedded Lisp type things. So if you want a Lisp that uses LLVM and you want it embedded in your environment, you can do that. There's a Lisp for that too. So that's what all these Lisps buy you. There's a thing called the hyperspec, and there's a link for it here. And the hyperspec is basically the Lisp standard. It's pre-ANSI. There's another one which is CLTL2, which addresses later ANSI revisions. But the hyperspec you can link into your Emacs session or your environment so that anytime you're on a function, you can look things up in the hyperspec. For example, and this pulls up the hyperspec. I'm using it on a browser in Emacs, which is not terribly fancy, right? But the cons function, all the things from the hyperspec, or you can just use your browser. So where's the hyperspec? I must have a link for it somewhere here. Here it is. And this is basically like the book, Common Lisp, the language. The browser, there we go. A little slow. Xorg is not working as well as it used to. All right. So things to know about Common Lisp. There's no class path, and this is really one of the joys of Common Lisp. You load files to your heart's content. You fire up your Emacs REPL or your REPL in whatever environment you're using, and you can just load packages to your heart's content. So if I'm here in my slime thing, if I want to Hello. Oh, right. So I'm using a tool called Quick Load. This tends to be how most people will load their projects. It's basically like Maven. Um, and so it knows about repositories where projects lie. In this case, I loaded the Clojurian project, which is a project that I wrote, but it's out. Anybody can load it. And it will let you use Clojure concurrency primitives. Let's see if I have them handy here somewhere. So it basically implements all these operators that if you're a Clojure programmer, you'll be very familiar with. And they work the same way in Common Lisp by and large. But the quick load tool, uh, the quick Lisp tool can load thousands of projects that are out there. And the fact that you don't have to worry about a class path means you can load them from anywhere. They don't have to be any particular place. If they're accessible on your file system, you can load them. Uh, Another thing to know about Common Lisp is that it's a compiled language. Um, so when you do something like, well, first of all, there's a compile file operator. But when you do a Control C, Control K, like you would do in Clojure to compile a file, um, in Lisp, it's actually going to spit out a compiled file representation, and then it's going to load that compiled representation. So there's no just-in-time compiler like Java. Um, you're always immediately bringing a compiled representation into your image. And what does that mean? Well, it means you can disassemble your functions for starters, but let me show you a little example. One that I know Gustavo liked. Let's see. Okay. This is what it means to have a compiled list. So I'm going to I don't really want you to look ahead here, but I just compiled add, and we can look at what was generated for add. And these are the instructions that are executed when you invoke add. And you can see that it's calling this generic plus here. And it's got capabilities to check for the wrong types of arguments, the wrong number of arguments, generic plus in case you're trying to add numbers that aren't integers or aren't fixed nums, or even complex numbers, which is one of the things that the Common Lisp numeric tower gives you that the Java numeric tower does not. Um, but so we're looking at our version of add. What if you want to optimize your add? Um, what if we know that A and B are fixed nums, which is to say integers that can be represented as unboxed objects, immediate representations. So it's not a pointer to an object that is a number. It's something you can stick in a register. And so now I'm telling the Common Lisp compiler with this declare statement that the inputs are fixed nums. And this is one of the things I love about Common Lisp, the declare statement, that you can optionally declare types at any time and reap benefits from that. Performance benefits or type checking benefits or whatever you want. So there's no need for an additional linter, or there's no need for like a specification language like Clojure.spec. You can just fold it right in, and every Common Lisp expression that lets you introduce variables or parameters will let you declare what they should be if you want to. So I've declared them here. If I disassemble add, do I get a more efficient representation? Well, it changed. We're not calling generic plus now. We're calling Alex signed big num. And that's still not maybe as efficient as we want. Maybe we want something that isn't doing a function call at all. Well, one of the reasons it's allocating a big num is because A and B may be fixed nums, but the result may be a big num. And a big num is something that's more than the size of a fixed num. So in Java, you have big nums if you use special libraries, and in Lisp, it's part of the numeric tower. All the overflows and conversions and everything else are implicit. You can go into a big num representation at any time. So I'm going to declare the result of A and B as being a fixed num. And if I disassemble it now, looking better, looking better. I'm not quite sure what this means, but we're doing a type check still, and I don't even know what this does. I don't read this assembler very well. I'm not an Intel assembler guy, but it still doesn't look as lean and mean as I'd like. What am I forgetting here? Well, another thing you can do with Common Lisp is set optimization settings. So by default, when you go into Common Lisp, it's using kind of reasonable safety and reasonable speed parameters so that you're not going to seg fault if you feed in a bogus argument. Can you hear me? Just checking.
Yeah, yeah, perfect, perfect.
Okay, good. So here in this declaration, I'm setting it local to the definition of add. You can set optimization settings. Here's the optimize statement here. You can set these, globally in your environment, but you can also set them on a scoped level. So now I'm saying that the add function should be compiled with the largest possible speed, which is 3, and the least safety, which is 0, right? So that means if you tell it you're going to pass it a fixed num, it better be a fixed num, or you could seg fault, depending on your Lisp implementation, because you're trying to generate lean, mean code here on the add. So we compile this, and we do a disassembly again, and we go down to our new disassembly, and lo and behold, the whole function is now 6 bytes. It adds 2 numbers, and it returns a value. So bingo, that's what we wanted. And this whole interactive thing, you have optional declarations, optional types. You have a real compiler that you can manipulate and interact with. You can see what it's producing. I love these things about Common Lisp. They're fun. I just think it's great. And they're immediate too. So if I compile the file, oops, well, I got a bunch of bogus stuff there. Never mind. If I compile files, though, they go to the file representation, and all the compilation is done, unlike the JVM where, if you were to do a performance test with the JVM and Clojure, you need to make sure you fire up the JVM so that it will use the JIT and do the optimizations, and then you have to make sure you run the code for 2 minutes to exercise all the code pathways to make sure that the JIT has been applied to them. And eventually Java will do a great job of making your code run fast, but it's a different model of doing things. Any questions so far?
No, not for me. That was great. Pretty
Yeah,
awesome that it's native.
it's but the explanation was crystal clear, so it's no questions.
Anyway, it's something that I love, and I really, I look at Clojure programmers that I worked with who are, we had Clojure.spec, which has for years been an alpha, and I don't know, it's when will it be final? And we had prismatic schema before that, also called plumatic schema. And now everybody's about, which linters should we use, and can we make it run in your Emacs buffer, and do we do it before you get check-ins? There's just no need for all of this with Common Lisp. The type declarations won't do generation for you like spec.alpha will do, but it does everything else I wanted to do, including checking for bogus arguments. So now that I've got here, I have a new version of add, and I'm going to turn safety up again. I'm changing it from when you compile it speed 3, safety 0. We call that Blastoff mode. But we don't want Blastoff mode especially if you're debugging, you're doing development. You might call it wrong. You don't want something that's compiled in Blastoff mode, because that's like asking for your program to crash if you abuse it. So here I turn on the usual safety, speed, and debugging parameters, and I invoke it with something that's not a fixed num. Okay, I'm doing the 10 to the 100th, and I'm going to call add with 10 to the 100th. And here I'll just paste it into the REPL instead of. And lo and behold, you get a reasonable condition. And this is one of the things about Common Lisp that's different too. So it's telling you what your value was. You'd be able to inspect it if it was an object or something, but it's not a fixed num. And this one is not one that will, you could have many Common Lisp conditions will let you enter a new value. This one doesn't, it's not set up for that. But anyway, you can debug and see, and you get basically type checks. So, which is something you would get from spec, but never in a production environment, right? You can never run spec in a production environment because it slows down your Clojure code too much. Whereas in Common Lisp, it's quite reasonable to get reasonable levels of safety and speed. You very rarely compile for Blastoff mode. You optimize when you need it, right? Anyway, I just wanted to show you this prelude to the condition system.
Yeah.
Gotchas if you're using a compiled Lisp.
As a comment that I would like to share, the fact that blew up and the amount of the stack tracing was just that amount, that's great.
Well, sometimes it can be a little too lean. So some Common Lisp, like the SBCL Common Lisp compiler, is really amazing. It does excellent type inference, and if you leave it to its own devices, it will often compile away a lot of your stack frame for debugging, right? So you might want to tell it to use debug level 3 and preserve as much data as possible. So sometimes you'll get into a stack trace and you'll say, where's all those functions? It might have inlined them. It might have done any number of things.
Yeah, but you have
them.
control over that, right? You have granularity.
You have control over all of it. It's great, but it can also surprise you, and that's why I have this gotcha section. When you have a compiled representation, when you're going to spit out, so say you have a constant, and the constant is a list or a string or whatever, there's a hash code associated with your constant in your code, right? So if you compile the Lisp and it gets spit to a FASL file, is what the compiled form is, FASL, you want to make sure when you load that compiled form into a subsequent Lisp session that it still has the same hash code, for example. And so there's a lot of care that needs to be given to how things are compiled and preserving things like their hash codes and equality and EQ-ness. And we haven't talked about equality in Common Lisp, but it's a little bit more restrictive than Clojure in order to support these compile time goals. Also, sometimes when you're compiling things, like if you're writing macros or something, you may execute all this wonderful logic, and then the compiler will say, hey, I can't find it. That's because the macro is spitting out code that's meant to be loaded at load time. If you want it to be evaluated at compile time, you might need to use eval when, where you can say when the code is supposed to be evaluated at compile time, at load time, or at execution time. Or you may need to make a special make load form will let you make special reloadable representations of things that aren't normally loadable by default. More tools, again, to control these things. Most of the time you won't notice, but every now and then you're going to scratch your head saying, why can't it find this thing that I defined here? And the answer is because it wasn't supposed to have a compile time presence. And if you want it to be a compile time presence, then you will need to say eval when compiling. Okay. Literals. Literals in Common Lisp tend to be different. If you have literal strings. Yeah, sorry, question?
Jean asked if the eval when, and I forgot the last one, sorry, if that's related to defwant on Clojure.
No, defwant's it's similar, but defwant is really just saying don't rebind this variable. And for instance, in Common Lisp, you would do that with defvar, which is the same as defwants. Right. So if I say now, if I say defvar 1, 2, 1 is still 1 because defvar is like defwant. So it's not a compile. It's not an eval when thing. It's just the semantics of the operation. Right? Don't bind it if it's already got a binding.
Okay, got it.
On these literals, when you include string literals, it used to be back in the day we worried a lot about how much memory we used, and if you had a program that had a ton of literals, big dictionaries, huge perfect hash tables, whatever else, you would want to put that in read-only memory so it could be shared across multiple instances of the program, and also just so that if you have to restart your program, the read-only segment could be kept in memory. And so you should always assume that your literal values in a Common Lisp program are read-only, that you cannot go and start setting the values of star name, changing the characters in it. Yes, Common Lisp is mutable, but don't mutate your literals. And similarly, on that same subject, this quote 1, 2, that's a literal. That will, you don't want to try to change the 2 in that list. As opposed to list 1, 2, which is going to allocate a new list on the heap in which you can mutate. Not super newbie friendly. Just be aware of it. Chances are you won't run into it too often.
I have a question.
Yeah.
Okay, so you just mentioned the topic of mutability. I wonder what's your take on, do you agree that Common Lisp is more mutability friendly than like for say Racket?
I haven't used Racket, so I don't know, but everything about Common Lisp is designed to support mutable operations. So
Yeah, but
you
would you
can
say they
use.
incentivize that?
I don't think of it as incentivization. I mean, at the time the language is designed, this is how we did everything, right? Nobody
Okay.
was worrying about read-only data, read-only data structures like Clojure, right? Immutable
Okay.
data structures. That wasn't really a topic of conversation. So
Okay.
it sort of just is, right? It's in the same way that the language C is. It's mutable. Interesting question though that you would think about designing it that way. The beauty of Common Lisp, and I'll show you an example later, but you can use read-only data structures in Common Lisp. It's just that they're not part of the standard. But if you want to use read-only sets and hash tables and lists and vectors, there are packages out there you can load that will do that and behave in that way, similar to how Clojure's persistent data structures work.
I think his question comes from the same place mine came when I asked you about this, because I said something like, "Hey, isn't then Clojure safer than Common Lisp?" And yeah, but it's also safer to walk on a bicycle without little wheels. So y-
Yeah, I guess that makes
Yeah,
sense. And I guess I should clarify what I mean with incentivize, because for instance, you said C, right? And C, yes, it was designed from the ground up to be mutable, but I would say the way that the libraries, like especially the header only libraries for C, they actually make you really think about mutability all the time, because they have, for instance, arguments as output, right? Because C doesn't have multiple returns such as like tuples or something else, so they actually have like arguments that they expect you to mutate, and that is your output. So you are incentivized to think like in a mutable manner when you're using some header only C libraries. So I was thinking, is Common Lisp the same? Do they have some sort of like mindset that they are using mutability from the ground up, aside from the design of the language?
If this is about like side effects, I think like you're instead of like generating a new value, but in Schema, I think they have like if you're modifying a value by a side effect, then you have like the exclamation mark, and that's supposed to be like kind of like a safety feature, so you can avoid that.
Yeah, yeah, I think
Common
that's
Lisp
related,
doesn't.
yes.
Yeah, so Common Lisp doesn't have that natively. The philosophy I get from Common Lisp is it's not going to incentivize you really either way. It's going to kind of let you make your own decision on that.
Yeah, that is my
Um,
understanding. But I played very little with it. It's like it's a hybrid, but not it's not meaningless when you say that. It's really that. It provides you can do whatever you want. So that's why I ask, because maybe there is a mindset that I should be aware.
yeah. So I think like Doug Hoyt in like one of his books talks about this of just like locking down your own specific environment, so that you can basically make those rules for yourself. So
Okay.
if you want it so that every symbol that ends with an exclamation mark indicates that to the compiler that it's intending to change a value that previously existed in memory, you can
Mhm.
do just that,
Okay.
um, which is kind of unusual and kind of cool about Lisp.
Okay. Dave, are you there? We can't hear you now. Are you talking?
Yes. Hello.
Hello? Oh,
I.
jeez.
Oh shoot.
No, 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 no. I think we can hear you. I think we can hear you. Go on.
Yep, can hear you.
Now it's back.
Hello. Testing. Testing.
No, it's
Okay.
working. It's definitely
So what I
working.
was going to say is, okay, there's some of the APIs like there's reverse and n reverse. Reverse will not mutate its arguments. N reverse will let you reverse a sequence, but it reserves the right to mutate your sequence so that it can do it efficiently. So there is thought to, some of these operations about, you know, you can mutate it if it will let it be more efficient.
Yeah, actually,
So
that's a
you
good
got
point. And the N stands for non-consing, I think.
let's see, reverse. Yeah, of course. Here I'm going to go and mutate a literal. So and then n reverse ABC. This one could just potentially try to mutate the literal. You could potentially get read-only violations, but anyway. That's why a lot of these functions are like this. So they're certainly aware of it. In general, though, I think Common Lisp will try to let you do whatever is most efficient.
Okay, that's good to know.
All
Thank
right,
you.
where was I? You talked about this a little already. So you can declare locally in your code, and you can also use a function called, or a special form called declaim, which is just like declare, but you use it at the top level to set sort of default settings for your environment. And we went through that example. Uh, this is something that I really like. Is once you have those types in your compilers, I showed you the example where you pass in a non-fixed num where you've declared a fixed num, but compiler checks run a lot deeper. Now, this is not static typing. And for me personally, I have no interest in static typing. I like dynamic typing just fine. But I love that Common Lisp will do many more compile time checks. And the example I use is I can, in my work environment, we have build scripts and libraries, and you use your Clojurian again or whatever else, and you build your Uber jar files. I could put my grandmother's cookie recipes in a file with a CLJ extension. They would go into that jar file, and nobody would complain about it until some other library loaded that jar file as a dependency and tried to execute that file. Uh, that's just way late in the you've deployed this thing and now you get the error of grandma's cookies being in a Clojure file. I kind of really hate that about Clojure. It's and this philosophy of maps all the way down means even though your function, your Clojure function, may only recognize one useful keyword in its input, you'll never get a compiler warning if you give it some other keyword that's of no use. And that's their maps all the way down philosophy, but I like compiler warnings that tell me about it. And let me give you just an example here. Uh, yeah. So in this example, may be broken. Can you see this? Piece of buffer
Yeah,
size.
yeah. This size is, yeah. This is better.
My control plus might work. I just don't know what my key bindings are like right now. So the compiler can't tell what kind of object C is. There's no declaration. And here we're going to use a format directive. And by the way, I love that they ported format to Clojure. I use it all the time in Clojure. If you're not familiar with it, it's a really useful tool for formatting text strings. Anyway, this tilde-C directory argument expects a character. Now, a lot of format arguments will expect things that could be nil or something, like, you know, tilde A expects a string, but it'll take nil. But tilde-C is more picky, and according to the standard, tilde-C does not want nil. It wants an actual character argument. But if I compile may be broken, you'll see compilation finished, no warnings down in my mini buffer. Whoops, well, I can't keep it highlighted for you. But here, now I'm doing this test by saying unless C, so C could be nil. I'm letting it know that we're passing in a nil here, basically, because of the constructs that are active. And I'm getting this error, and it says unreachable code. It's not telling me that the C being passed to format is invalid. It's a little bit inscrutable in that way, but it's saying, hey, this code is not reachable. And the reason is it knows that this code will signal a condition and accept, an error, because you're passing nil in where a character was expected. And I love getting these when I'm working in Common Lisp code and I'm just, I'm in the zone and I'm writing code and I'm moving along. I love getting the errors right then that say, hey, you wrote something that can't be reached or something that won't work. And it's not, again, not static typing, but it's worlds ahead of Clojure, and it saves me lots of pain because I don't have to get to the testing phase or the production phase to find out that I wrote broken code. It's right there the minute I say Control C, Control C. Anyway, maybe you like that too. So we're going through reasons you might want to use. Are we doing differences or reasons? I forget. Okay. That I was just describing, right? So here's a function in Clojure that would only recognize and act on a keyword Y. It's not passing it to another function. It's, there's no reason for this function to exist if you're going to pass it Z, right? It'd be nice to get a compiler error here, but that's not Clojure's bag. It will never give you these compiler errors. Whereas if I do this in Common Lisp and I define this function X that takes a Y, expects a Y, and it's optional, and I pass the Y, it's fine. I pass the Z, you get an invalid argument. I love getting that feedback at compile time. So if that's your bag, it's good. Common Lisp is good. Fixed nums. So certainly Java has, when you talk about a primitive integer in Java, that's an unboxed integer, right? Something they can fit in a register, something that they can allocate locally to an object without having to allocate another object to contain the number. And that's what fixed nums are in Common Lisp. And you can do lots of fun things with fixed nums. I have this, just as an example, if you ever wanted to go there, I have this clustered inset GitHub thing that basically uses fixed nums to store groups of integers. It does a set representation, but there's SBCL's fixed num is 62 bits. So I can store 62 bits representing discrete integers in a single fixed num, and it's nice. You can play games with fixed nums and save a lot of memory. If you're trying to write code that doesn't cons, perhaps for a game or something, if you're implementing a game in Common Lisp, and there are games in Common Lisp, you don't, every garbage collection is a potential point where it might stall for the user. So you tend to be more aware of garbage collections in some Common Lisp applications. And fixed nums is one way you can reduce garbage. I have an octree representation in a game of mine. and I encode the x, y, and z coordinates of a point in a single fixed num because I give them, they're each 20-bit coordinates, and that lets me not allocate any memory for the point, basically, of every object that is storing a point. Similarly, cons is in Common Lisp. I mean, Common Lisp was built for the cons, and in Common Lisp, a cons is a two-word entity, right? It's got the car and the cooter. It's just two words. And of course, on a 64-bit architecture, it's two 64-bit long words, really. There's no such thing as that in Clojure and on the JVM. There's a cons object in Clojure, but it's got the Java object overhead, which is 8 bytes, and then you're going to have your car and your cooter. And anyway, it's just a different thing. Common Lisp is really oriented towards cons. Okay, equality. So in Java, everything is equal mostly, right? You use equal all the time, and you take it for granted. And there's some pretty amazing things that equal and equality and Clojure give you, because a lot of programmers aren't aware of it. But when you say equals, vector and a list, and you get true in Clojure, well, that uses a little protocol under the hood called equiv. It's not actually a single is equals method. They've gone the extra mile to determine equivalence. But you also pay for this thing. So while you can compare with amazing abandon and Clojure all kinds of trees of objects, doesn't mean it's cheap. It is super convenient though, and I miss it sometimes in Common Lisp. So this is not in Common Lisp. About the best you can do is if you want to compare two trees of objects and they're both lists, you can say equal p. So these are, EQ means identical. EQL means identical, but we'll also consider numbers and characters. Equal will do more extensive checks on strings, maybe, I don't remember, you'll have to look it up, and lists and what have you. And equal p is the most flexible. It will let you compare depth, recursive, depth-oriented lists and things like that. I'm stumbling over words. Don't know why.
Does it do it by itself?
So just so you know, and sorry,
does equal p compare depth-oriented stuff by itself, or do we have to put a function on how to do that?
I'm sorry. Oh, do you mean you want to define a new function for equal?
No, so equal p. How does equal p is able to compare stuff on a depth level? Like, is it already geared towards that, or I need to pass a function to it in order for it to be able to do that? That's my question, basically.
So the answer is most of the time, equal p. So returns true if they're equal, or if they have components of the same type, and they're equal p. So characters, numbers, fonts, arrays, right? It looks at the dimensions and things. Structures will look at each slot, but other objects, more complicated objects, it won't. So equal p will compare hash tables. If you create the hash table to use equal p, and that's the thing, when you use hash tables, you want to say which sort of equality you want to use to compare keys, right? It defaults to EQL. So you'll need to develop some awareness of which equality method you're using, but there's nothing that's going to generically traverse in a depth-first fashion everything in Common Lisp like Clojure will do. There are packages out there that will probably do most of what you want for you, but you'll have to dig through them in Quick Lisp and take a look around. I don't use any of them, so I don't know them offhand. Anybody know any offhand? Anyway.
No, I don't know any. But I guess this is the type of thing that you make your own equal if that's the case, right?
Right. Although you can write generic code that will generically look at the slots of objects and compare them, and you can write some pretty generic stuff. It's just not included in the default list, and that's why I think you'll be able to find packages that will do 95% of what you want. but you may need to go the extra mile for certain situations.
Oh, definitely. I think we found two game engines in Common Lisp, which is like probably it has 95, probably more of what you want.
In Clojure, you have namespaces and they're hierarchical. In Lisp, you just have packages. It's flat. You can call the packages all kinds of things. Um, and but packages actually are pretty flexible as well. You can import symbols from other packages. You can export symbols that aren't even in your package. You could like I do this in my own setup. I have a utility package. I import arrow macro definitions from one package and I export them in my package, and I don't have to define them or copy them or anything else. I'm just sort of sharing references to functions and macros through import and export of names on packages. So it's a little different than Clojure, but it's anyway. You'll like it or you won't when you get there. Clojure has much better destructuring. So when you declare a function or when you make a let block, you can do destructuring pretty much any place you bind variables. And that's one of Clojure's great contributions. Uh, Common Lisp doesn't do that. So destructuring is done to a certain degree on function declarations, but there are some macros that will do them. I use the one in the standard is destructuring bind. That will let you do things similar to what you're doing in Clojure. So you can take a list and bind all the variables in the list to separate all the elements of the list to separate variables or what have you. I also use a tool called metabang bind, which lets me, it has a bind function, bind macro, and it lets me do binding in my let, and it also has a lambda bind to have a kind of anonymous function type of binding. So there are packages out there that will help. None of it's quite as elegant as Clojure on the destructuring front, though. Of course, you don't have vector syntax, and decisions were made. Common Lisp's con, for example, is different from Clojure's. In Clojure, you have cond, A, B. You have test one and consequent one, and test two, and consequent two, and so on. And if you want your consequent to be multiple statements, you'll have to wrap it in a do. Common Lisp went the other way. They parenthesize every cond expression. You have your test first, and then the forms are sort of in an implicit do, or in Common Lisp land, that's a prog n. Prog n is like Clojure do. So a little bit different. You're going to have a few more parentheses in your code. I don't think one is right or wrong versus the other. You could probably write your own cond macro to do it Clojure's way if you wanted.
Just for the sake of completeness, Clojure has the do, Common Lisp has the progend, and Racket has begin. So there's that.
Arities. So Clojure's big on arities, and the way that you're going to express arities in Common Lisp is through use of optional arguments. So optional, rest, keyword, these are all ways to express optional arguments and therefore optional arities. It's not quite as readable and elegant as Clojure, but you can definitely do it. I use this to simulate. I have a Clojure compatibility library, and so I emulate many Clojure functions that are multi-arity, and I just use it using these Common Lisp optional arguments and so forth. Once upon a time, Clojure liked Quark syntax, so everything would be my fun, colon x1, colon y2. Clojure doesn't do that anymore. Now we always just pass all those things in a map, right? But Common Lisp is always Quark arguments. Map support is not generalized the way it is in Clojure. So you use amper key lambda list keyword to declare keywords. In Common Lisp, all keywords are in the keyword package. So you can't create a keyword in some other package. If it's a keyword, by definition, it is in the keyword package. Common Lisp, no lazy sequences by default. And of course, even Rich Hickey will tell you that if he had it to do over again, he wouldn't focus so much on the lazy sequences. He'd focus more on transducers. There are plenty of packages in QuickList that will give you lazy sequences in various forms. How does that look by when I say QuickList? Here's and this will go query the QuickList package repository, and these are all good places to start for things that I could import into my Lisp that may implement lazy sequences. And they'll pull the GitHub repo over, they'll load it into your system, and you can nose around the code. In fact, here, let's try that.
Yeah, this
It's
is one of the
compiling all the
things.
files.
This is one of the things that I remember when we played with Common Lisp in the server. You barely have to use the browser. You can basically live in Emacs. And that's great.
And while it's doing it, it's also pulling all, and now that it's compiled, if I load it again, it doesn't need to compile it again. It will need to recompile those files when I upgrade my Lisp, but it knows how to do all that automatically. And by QuickList pulling that in, that means in my it's pulled the Git repo into a local directory. So what was that? Native, maybe it's ultradist. Okay. Just want to prove to you it's there. Easy. Repos in here. But you can always, once you've done a quick list install, then you have all the source code there. You can go look at it locally. But quite as easily, you'd have to go separately on the command line and go get the Git repo and put it on your class path. And in Lisp, it's all right there, ready to be used and played with. Looping. Lisp has Common Lisp has this DSL, and some people love it and some people hate it, but it is very expressive and is also very efficient. So, for example, you're looping over for something in a list and you're collecting transformations of it. Why wouldn't you use mapcar or mapreduce? Well, let's mapreduce in particular. After 10 years of Clojure, I can tell you that when I use the Lisp DSL to do something that I would do with a MapReduce, I sometimes feel guilty for not using MapReduce. I can still use MapReduce in Common Lisp. But on the other hand, if I want super efficient code, the loop DSL can do something that MapReduce can't, which is it can optimize out all those function calls for every element in the Lisp. It can turn all of this into a nice set of efficient instructions that don't make function calls, except here for my transform thing, which is a function call in this example. Anyway, love it or hate it. You can loop. There's other looping primitives like do list and also a general purpose do where you can bind and iterate in different ways. But anyway, loop's fun. Maybe you'll love it.
One seems more complicated, like the DSL, because you always call a loop, and then you pass a different method of looping. Is that it?
Well, you can. So loop will let you do so many things. So for X in A, B, C. Oh, that's not good. Let's use 1, 2, 3. And you can do co-varying loops as opposed to nested loops. And of course, you can do that with map. You can co-vary over multiple lists because map will apply the function to one argument from each list. But you can't do it with reduce, right? You can't reduce over multiple lists. Something I'm sure will be coming to a Lisp in the future, but in there we go. So, I mean, you can do all kinds of things. You can do hash tables. You can collect. You could say, I could say, I could do a min or a max. Loop's pretty flexible, and there's other DSLs like this, like iterate uh, for series stuff. Oh, what did I do wrong here? Unknown loop keyword X. Oh, right. Sorry. As opposed, I can also go with, z equals zero. Z is like width is like a let. It just saves you having to introduce a let, right? I can make different kinds of bindings, some of which I'm going to iterate over, some of which I'm not. Oh, pardon me. I got a cat here who wants cuddle time. Okay. All right. Common Lisp. This is one of the places where you feel the dark corners of Common Lisp. In Common Lisp, sequences can be lists and vectors. It does not treat hash tables as sequences, and so the abstractions are missing. But lots of people have lots of packages that can abstract over hash tables and lists and vectors and other types by using Common Lisp's generic function capability, which we haven't come to and may not even get to tonight. But, so just preparing you. Maps also, hash functions. So when you're using maps, you got to be aware of hash keys. There's SX hash, which knows how to do it for all the Common Lisp types. Mostly you don't have to worry about it when you make a hash table. You just want to declare what type of equality you want to use. Lisp 2 versus Lisp 1. This will get you at first. So in Clojure, your symbols tend to be vars or things that look like vars but aren't. Like when you do a let, X, you're not actually creating, well, I guess you're creating a local var. In Common Lisp, you have symbols, right? So if I say I inspect that, I can inspect this symbol, and you can see the inspector says it's a symbol. The symbol value is unbound, and it has no function value. These are separate slots. The symbol is like an object. So you have a symbol name, you have a symbol value, you have a symbol function value. And that means if you want to call, I can say cons, try to take the value of it, but cons has no value. Cons is a function. I can say symbol function of cons and get the function. But I can also, if I wanted, I could say let cons, sorry, kitty, let cons, 1 and cons 2, right? So a Lisp 2 means you've got separate value and function spaces, and you never have to worry about smashing over a function you may want to call. I like to use count as a binding, as a variable a lot. And in Clojure, sometimes I'll say let count something, and then I'll try to call count later on, and I've already bound it to a value to an integer, and it's no longer a function. So I like a Lisp 2. A Lisp 2 doesn't bother me, but you'll have to get used to it. And if you want to get the so that doesn't mean you have to call symbol function all over the place. If you call cons 1, 2, a cons in the function invocation position is going to access the function of the symbol, as opposed to if I put cons here, we're trying to access the value of the symbol. And if you need to manipulate the function another way, there's a shortcut for symbol function, which is sharp quote is basically the same as calling symbol function, in the same way that quote, a single quote, is like calling the function quote in both languages. So
for me,
okay, well, this is good. I hope.
yeah, for me,
Yeah.
this specific case, like, of having one name being bound to different stuff. Like, okay, it can be either a value or a function. And don't know if this is because of my because I'm kind of new to it, so I I don't know more. I don't know better, but it seems like not redundant. It's something else. Ambiguous to me. Um, but well, since it's like it's from a standard, I think they had a good reason for that. Do you know? Do you know about that? Like, why did they decide to, okay, we're going to have uh both a function value and a value for symbols in Lisp tools?
That's actually a good question.
Well, my answer would be that it comes from 20 years of evolution of Lisps from different roots, right? So, for example, you'll see that one of the properties of a symbol here is also a thing called a property list. And it used to be that a lot of people building Lisp apps on certain Lisps would rely on this notion of a property list associated with a symbol. So some of these are carryovers from a different era, right? And from all of the Lisps that went before. Somebody else have an answer?
There's actually an efficiency reason for this. I came from I came to Clojure from Racket actually, and I looked a lot into scheme implementations because they are related, right? And the problem with being a Lisp one from an efficiency perspective is that since the functions and other values coexist in the same namespace, whenever you have a function call for something that is an argument to a function, you are forced to type check that, right? To check that the thing that you're trying to call is actually a function. Whereas
Oh,
if you have a Lisp2
that
with a
makes sense.
separate slot specifically for functions in your symbols, then you don't have to type check that. At best, you may have to type check the arguments, but that's a separate issue. But you don't have to type check the value itself because only like a function would go to that slot to begin with.
I see. Is it worth it though? Like in terms of the efficiency, because like Guy
Actually, it
said,
is
oh,
because
it is.
chess scheme, although it's a scheme implementation, it actually does have a separate function slot internally, just like Common Lisp. It
Oh,
doesn't expose that to the user, but it does have it, and it actually improves performance in chess scheme.
no, I didn't know that. Okay.
Yeah, just my 2 cents on it. The way I see it with Lisp 2, you can implement a Lisp 1, but you can't really go the other way.
Yeah, that
So it
also
just
makes sense.
yeah.
I'll just add that if one of the other things that's related to all of this is in Common Lisp, when I type a symbol foo, I've caused this foo to come into existence. If I try to take the value of that, right, symbol value of foo, in Clojure with a var, you'd probably just get nil as a default value. But in Common Lisp, if you haven't assigned a thing a value, it's treated as unbound, unless it has documented semantics of saying it'll be initialized to nil. But in this case, there's a symbol foo. It's got a value slot, but we've never put a value in it, and so you will get the variable foo is unbound error. And if you see that, that's why. So if I say another notion is that, well, I'll leave that for later. Here I'm setting the symbol value of foo to x, and now if I go symbol value foo, it's got a value and we get x. In the same way that there's a bound check for a symbol value, if I tried to go foo of 1 to access the function value is also undefined. So it tries to invoke, it says there's the function as foo is undefined, as opposed to the value of foo. And so these things are called boundness, right? So there's bound and f bound, which are functions. Note bound b. And oops, is it bound b? Yeah. Yeah. Okay. So there's bound p, which will tell you if a symbol is bound, and there's f bound p, which will tell you if the function is bound. Just so you know.
Okay, so they provide you granularity for these also. That's cool.
I mean, I have gotten to like the simplicity of Clojure. I mean, this is where Common Lisp, they had their reasons. I couldn't tell you what they all were. I was actually working on Vax Common Lisp when we were doing the standard, but I wasn't all part of most of these talks, so I don't have a point of view on it. But now, 30 years later, yeah, it feels like more work sometimes when you're doing that in Common Lisp, but it may be more opportunity too. It depends on what you're trying to do. If you're trying to implement your own DSLs and languages, maybe it's useful. I don't
No,
know.
no, I was not criticizing it at all. I'm just saying that the fact that
Oh, I
they
didn't think you
thought
were.
of that,
Yeah, sure.
like, if we're gonna allow you to have this feature of having a name meaning two things, we may as well allow you to check for the two different things. Like, it's consistent,
You
and
can
it's also
probably
consistent with
handle
the
it.
premise of being in a hybrid. It can do whatever.
Yeah. You can also, I'm pretty sure, handle the condition too. So if you wanted to write code that handled the case where something wasn't bound, maybe you're calling something indirectly and it's triggering unbound variable conditions, you can also handle these conditions in Common Lisp like you would exceptions in Clojure.
Okay, I see.
So all these things, all these errors are handleable in Lisp. The difference being that in Common Lisp, its famed condition system is restartable. You can restart from the point where the thing is being signaled, not some point where you caught it up the stack. And I'm not even prepared to go into that today, but the condition system is one of Common Lisp's fairly unique things compared to Clojure or many other languages.
Speaking about that, now that we definitely, I think we're going to have interest in the second day, do you think this is a good place for us to stop? Or do you want to close something else with something else?
We can stop anywhere you like. I mean, I've got so much here that's just on the
Yeah,
languages.
yeah, I look at the
Um,
buffer is 58%.
yeah.
So yeah, so I
Well, the
think
other thing is,
sure.
yeah, no, I we could definitely do a second. The other thing is, how do you use Lisp to do things? And I have a whole separate. This would definitely be a separate talk, which is, let me just give a quick bit of code on the screen here. Um, Basically, if you want to emulate Clojure, if you wanted to implement Clojure seeks and Clojure lists and their vectors and seeks on them and immutable, you can do all that in Common Lisp. And I have an example of how you do that using the Common Lisp object system and generic functions. And this, at any rate, things to leave for another day. But there's just so much interesting stuff there. Anyway, I leave it to you.
Okay, so I'm gonna propose for us to finish this section of the main differences with recursion let, if that's doable, in like 10 to 15 minutes. And then we close it, and then the second day we start with why would you use Common Lisp? What do you think about that?
Um, why don't I instead just go down the high level of these other points just to intrigue you, and then if you want, we can come back to it instead of going deeper into the differences, which is pretty mind-numbing at this point if you're a Clojure programmer who's never Lisped. There are a few things I think you'd find really interesting that I'd like to just bring up.
Okay, feel free.
For
You
example,
are the
the
boss.
ability of Common to generate executables. Yeah.
So go for it.
So yeah. So at the high level, okay. Yeah. So at a high level, um, there's a reason that some people use Common Lisp to write games, and it's sort of twofold. One, you can generate executables from your Lisp. In fact, when you've spent all afternoon loading all those fun packages and playing with it, and you've got stuff sitting there in memory, you can dump that whole thing as a Lisp image and resume it at a later date. And You can also use that ability to dump images to dump executables, which you could ship or give to friends, right? They've got everything built in. They don't need to run a list. They just run an executable. You can generate executables for scripting.
Okay, I gotta
That,
say that this is a big deal. I gotta say
I
that.
think it's neat.
Yeah, because and why I also need to express that why that's the case. Because we have a game that we made in Common Lisp, which is a Tetris game. And when we were discussing how to ship this thing, everybody was talking about shipping SBCL with it. And just like when a person clicks on it, the person is actually clicking on a script that will bootstrap the entire thing, and it will inject the function to SBCL or whatever. So there is a way to actually ship an actual executable. That's awesome.
And when you combine that with Common Lisp's ability to access shared libraries, so this has always been the pain in the Java ecosystem, which is if you want to use something that's written in C or C++ or Go that has shared libraries, that's difficult to do from Java. They keep working at making it easier, but face it, JNI sucks. But with Lisp, working with third-party shared libraries from Lisp, you just declare the shared library, you use the foreign function interface, and you can easily wrap third-party libraries written in other languages in Common Lisp code. It's really a joy to do. One of my repos out there is an encapsulation of the roaring bitmaps thing. There's a library out there called roaring bitmaps. It's big for if you need large compressed bitmaps. And it was just trivial to write Common Lisp code that wrapped it and made it usable from within Lisp. So you combine that with games where you need to access X functions or game libraries that are already existing, right? Two great things that go together. Non-consing applications, I would say, is another interesting thing, the restartable conditioning, but the ability that you're much more in touch with when you're allocating memory in Common Lisp than in Clojure. In Clojure, even doing a seek to see if a collection is empty, that actually allocates an object. Java Clojure is just a huge consing thing. You get away with it because Java top-notch GC, but it's a brute when it comes to allocation, whereas in Common Lisp, you can be quite close to your memory utilization if you want to be. CLOS, the Common Lisp Common Object System. Got to talk about that sometime. This, every OO language out there has flaws. Common Lisp Object System is designed to let you sort of build your own OO language to suit. I mean, it doesn't restrict you on anything. It just gives you tools to build your own OO paradigms. And when I say CLOS, I also include sort of generic functions in that, which lets you do, polymorphic dispatch on multiple arguments. And it has so many other flavors like method combinators, things that mean nothing to you now are worth talking about.
I think it was recorded the day when I was presented the object system of Common Lisp, and then I saw that, like, wait, do you guys have like multiple inheritance? Isn't this a big deal like today? It was quite a funny
To me,
reaction.
well, showing you, for example, showing you how I would implement the Common Lisp, the Clojure seek abstraction on lists in Common Lisp object system might be revealing, right? But yes, you have with Common Lisp object system, you can do multiple inheritance and you can do it any way that makes sense to you because you have control if you need it. You have control over how the method dispatch and method resolution mechanisms work. Also, to show you how the meta class capability works, the whole notion of a meta class means that, for instance, when I declare classes in Postmodern, a Common Lisp package that encapsulates PostgreSQL, here I have an example right here. So this is an example of Postmodern, which accesses the PostgreSQL database, and I'm using def class, which is Common Lisp Object System. I'm declaring, when I make instances of this class in memory, I can also instances on disk. So it's a data access object interface, right? And it proceeds by using this meta class at the bottom, and it's really slick. If you're prototyping this ability to declare your database schema and fold it in with your in-memory class representations, Oops. I don't want to change my phone here. Pardon me. Come on, dudes. All right.
Uh, Dave, did we lose him? Oh, it's back.
Hello?
Okay, now it's back.
Okay, yeah, I'm here. Anyway, I'm just so as hints of things that are pretty cool. If you're going to prototype a database app, this ability to do meta classes on top of class, the control is amazing, and it just saves you loads of time. It's just great if you're prototyping ideas or want to get a quick app off the ground, as opposed to Clojure, where HoneySQL is wonderful, but encapsulating database access not so much. Okay, well that's all I really wanted to hint at. Uh,
Okay.
Other than that, the last thing I will say is there actually is one thing. The analogy is I like Clojure. I love the JVM. The JVM is incredible. But my analogy is sometimes when you go to the grocery store, you don't want to take your 18-wheel truck to go pick up groceries. And that's what it feels like sometimes with the JVM ecosystem. Big, huge jars. Nothing's ever lean and mean. You have to work so hard to make anything you can distribute. Whereas in Common Lisp, it's a lot more easy to just get up and go and write something and distribute it. And sometimes I value that, and I'm willing to venture into Common Lisp's dark corners to have that. Okay, all done. Thanks for listening.
No, it was a pleasure. So, do we have any more questions, people? And again, I think we are pretty settled on a follow-up. There's no problem in follow-ups. This is not a known issue at all. So if people are interested, I think I am
Wrong.
interested.
I would like.
Guy is also interested in that because for sure I just noticed that there's so much more to unpack. Um, so I think we have the quorum. I think we have the time, and we can schedule a new day. Um, and I think you do have a great way of presenting this. So I don't think that's a problem. So questions, comments. Uh, Up for a follow-up. Yeah, I think we have people interested in a follow-up. The only thing that I gotta say about the ending, which is like nothing wrong with Clojure. I also agree that there's not too many things wrong with Clojure, but I'm not a fan of the whole way of reporting errors that I think Clojure needs to suffer because of the JVM. Um, so everybody that I talk to, we all agree on this, that whatever about the features, but the errors they need work. They need more work for sure. More reporting them in a very pleasant, like it needs to be pleasant to debug as well. Okay. It's all nice when they're using our threading macros. That's fine. But if it errors out, we should not have like a big pile of sometimes useless information on top of it. That's my only comment about that.
I have a
On
last
a,
question.
on
Go on, please.
Yep. No, go ahead.
So, on the close part where you were showing F class from postmodern, you showed a way to find the database schema, and you said that this was a great way to prototype and test ideas. For example, if I have, so imagine you're starting right now, writing the Galaxy class, you have an ID and an octree, and then okay, I think I need the star system map now. If you add the star system map as another column and then reevaluate this form, will it rewrite the table on Postgres as well? How does it work?
Great question.
Postmodern, I don't think it has any built-in schema evolution capability. And for me at the prototyping stage, this is my create table logic, right? I have a thing that maps create table down all the classes, and if it exists, it says it already exists. It won't evolve it. But the ability to have all this information in the CLOS model means if you want to use a traditional schema evolution tool like Flyway, you could actually generate, you could use this data to generate your Flyway declarations if you wanted to. But it doesn't have it built in. There's no schema evolution built in.
Yeah, and to be
Right, okay.
fair, what you proposed, Guy, would be a little bit dangerous because imagine adding 3 columns and doing an accidental Control C there. Like
Mhm.
you may create some undesired side effects on the database without, and then you have to do migrations on all that nonsense. So
Yeah, no.
I think having a little bit more control, like only being only mainly read only, it's great. Because if it was because of the interactive environment, okay, I'm not saying that it would not be a nice to have. Of course it would, but I can see why they would argue to not do that.
No, definitely. I was just thinking, hey, how powerful can this be? Actually, it depends on um how much control you want to have over it, basically.
Exactly,
Which is cool.
exactly, yeah, exactly,
Basically, you have you can do whatever you want.
yeah.
Yeah, that's
Uh,
right. And
And there may be packages that already help with this. I don't know. I'm a novice in the database from Common Lisp environment.
okay, okay. So any more questions and comments from the audience? Marinho, do you have a question? Do you have a comment? This is so deep. It's like your vibe, Marinho.
No, I really need to take the time to look more deeply into Common Lisp, in particular SBCL, because well, it's not a secret that I'm into language design, and I really like the interactive environments in Common Lisp.
Yeah, it's
One of
it's
the
great.
uh, one of the reasons I like Common Lisp for language design, whether it's a DSL or something else, is Common Lisp gives you this toolkit so that you can generate labels to branch to and go tos and things like that. So if you're writing macros to do complex flow control things, um, Common Lisp's willingness to give you all the tools, no matter how dangerous they are, is really helpful. And there's a language that somebody has written out there called Colton. I don't have a link for it here, I don't think, which is a statically typed language that's built on Common Lisp that they use in a quantum computing application. And they're hiring all the time, by the way. If you're looking for jobs doing language design in Common Lisp, they're hiring Colton programmers. Uh, but Common Lisp is really a great tool if you want to do things that are going to generate code um, and blocks and bindings and all those things.
Yep. So if we don't have any more questions, I will finish the recording. So 3, 2, 1, and